any color you want.
Look at this.
Oh god. Oh
Got it.
god.
You're still adopted. Hello, good people of the internet. You really showed me that you guys want the next part of this series, and today your wish came true. We will complete the backbone structure of the sheet by reading the local player's information, but also reading the whole entity list. We will retrieve the health and position of all of the characters in-game, which will help us to easily create an ESP or Aimbot in the next episode. So make sure to subscribe, like the video, and write a comment if you haven't already, so that you will be notified when the next part drops. But remember, enjoy this showcase and tutorial now. Welcome to today's showcase. I am running Counter-Strike 2 in Dash Insecure mode, and we can take a look at what you will have at the end of this tutorial. So, we will read all of the entities inside of the game and our player. Let's take a closer look. Here we have the ImGui window, and we also have the health of the entities, of all of the entities in the server, and their position. So this is real powerful stuff that you will learn in this tutorial, because when we have these or this information, we can create the wall hack or ESP, can create the aimbot, we can create a lot of stuff with this backbone structure. So I hope that you enjoy today's video, and good luck. And we're at the beginning of part 2, or maybe part 1. I haven't made my mind up yet on the title of this video, but we will begin this tutorial by checking that we have under properties, in the launch options, we have the command -insecure. You must have this, otherwise you will be banned, because back will validate your files and they will ban you. So please use -insecure. Thank you. Now, the next step will be to go in game. So let me do that. Alright, so we're at the main or our home page in Counter-Strike, and we can check that our -insecure flag is correctly working by going into play, matchmaking, casual, then select a map, hit go, and you should see this message telling us that we have -insecure mode on and our file's signatures won't be validated. So that's good. Now we can go into our practice game. So we will go into practice instead of matchmaking, then select the options infinite ammo and infinite warm-up. I will use Dust 2. It's easy to navigate on that map, so I'll hit go now. Alright, we're in game and I'll pick the T side. So for your ESP and aimbot and all of that, we will need some fundamental pieces of information. So in this tutorial, we will focus on getting our player. So this player, he has 100 health, he has a position, and we will also get the other entities. So let me spawn in some bots. They will work as other entities. So let's let me clear that. We use SV sheets 1, then bot stop, then bot add, and just repeat this to add some entities. Now we have 3 teammates and 4 enemies. So we want to find these guys information as well. So not only our position and so on, but also these other entities, we often call them. So how do we find the entities and our player from the game, or in ghidra that we will use. And it's actually pretty easy. We can find out what's in common for our local player and these entities, search for that value, and then go from there. So we can see that our character has 100 health. If we take damage, it goes down. And these other entities also have 100 health. So let's find our character's health and go from there. Alright, so I have opened Sheet Onion. Remember, don't open any sheets or create something without dash insecure. But when we have Sheet Onion open, we can search for our health value. So let's attach Sheet Onion to Counter-Strike 2. You can see that we have 100 health, and we will search for 100 in Sheet Onion. It's an integer, so it will be 4 bytes. Now we change the health by typing hurt me in the console. Then search for the new health value. Let's repeat the process to get even less addresses. All of these addresses seem to follow our health value, so we will have to find the correct address that points to the entity object. In our last series, the Left 4 Dead 2 series, we used the find out what accesses this address. So we used that by going into settings and enabling VEH debugger. Now, when we did that, we already sort of knew what offset to look for, but for CS2 I can show you how we can use ghidra to find the offset and don't waste time finding the correct offset here. When we have ghidra open, we can drop the client.dll into ghidra. We can find the client.dll by going into properties, local files, then browse. Here we choose the game folder, CSGO folder, then bin folder, then Win64. Here we just drag and drop. Here we click OK. Then, after it has loaded, we double click on the client.dll. We will let ghidra analyze the module, so we click yes and keep all of the default options. You can see a small window in the down right corner that keeps track of the analysis. We will wait for this to be completed before continuing. When it's loaded, we can go to the search tab and select strings. This will produce strings from the binary. What we will do now is to search for the m_iHealth, exactly like our Left 4 Dead 2 tutorial. We can double click on the string. This will bring up the address into our list. Now we will right click this address and find out the references to it. Here we have some references. We will check these code units if they have some offsets for us. You can double click on the unit, and on our right window we can see the decompiler, which makes it easier for us. We're looking for the iHealth, so let's scroll down a bit. Here we can see some similar offsets. We have an age controller, hide hood, and our iHealth. We have some think tick, but if we look below them, like or similar to our Left 4 Dead 2 series, we can see some what looks like offsets So 122 seems to be the H controller, 1164 seems to be the hood, and if we scroll down, the third offset, which should be the IF11, is 32C. Let's confirm this in SheetEngine by finding it. Now to check what these addresses has for an offset, we will use find out what accesses this address. This way we can directly see what the offset is and we can look for 32C. And would you look at that, we have our 32C offset. Now, because the 32C is our offset, RCX must be the base of our object. Let's add it in the address table as our entity base. Let's take the base of the entity and search for it to get a pointer towards our entity. We got over 200 results, but we're only interested in 2 types of addresses. These 2 will hold either the local player or the entity list. We can easily find out which one is the local player and which one is the entity list by checking if it holds multiple pointers to multiple objects or it holds only one object. So let's take a look at the first address. We right click on the address, select the address, then go into the memory viewer and dissect data/structure, define a new structure. And would you look at that, we have a bunch of pointers to instances of cPlayer pawns and cObserver pawns. Now, I think for the new CS2, all of the pawns have an observer and they have similar attributes. So now we just need to go to this entity list and read all of the pointers to the different entity objects. Isn't that great? We can also check that these entities follow our offsets. So the first one should be our entity, and as you can see, it has 90 health. Let's take a look at another pawn. Perfect, they seem to follow our offsets. Let's change the name of the address to EntityList to not forget. Now the other address should be our local player, so let's take a look at it in the dissector. Here you can see a pointer to instance of cPlayer pawn. That sounds like our local player. So if we step into the pointer and go down to our offset 32C, we should see our health. Would you look at that? So we have found our local player and entity list. Quickly before we end the offsets part, we'll have to find the origin position of the entity. So I couldn't really find it with ghidra for some odd reason, but we can also find the local player's position by using CL show position 1 in the console, then searching for that value inside of the local player. So we open the dissector again and go one step into the pointer, then just Ctrl F to search and our X position. Here we can see a 3-dimensional vector, X, Y, and Z value. Our Z value in SheetEngine is a bit lower, but I think that's fine because that position on screen might be from the view of the character or something. So we'll pick this as offset CD8. Let's now write down all of the offsets and addresses that we have found so far, which comes down to local player, entity list, and 2 offsets, the health offset and our position offset. Alright, great. We have our addresses and offsets. Let's create a new project in C#. It will be a console app. And very important, it will be the .NET 6 framework. First thing we will do is to remove this preset or default code, then install some NuGet packages. The first NuGet package we will install is ImGui.net. Make sure to install the version 18971. The next package will be 6 labors. After that, we have veldrid.imgui. Then vortis.mathematics. Make sure to use version 1.6.2. The final graphical package will be clickable transparent overlay. Make sure to use the version 6.2.1. We can now install the memory library, which will be Swedz64, because Counter-Strike 2 is now 64-bit. We also need to match the architecture in our program, so going to project settings, then build, then use the 64-bit architecture. Let's add the usings now for these NuGet packages. Now, because I don't have it, I will add a namespace and a class program with its main method. To use ImGui, we will inherit the overlay onto our program, and because we did that, we will need to implement its render function. In our class variables, we can create a new instance by the Swedz library, and in the constructor, we will have the process name. So you can find the process name inside of Sheet Engine. But before doing any reading or writing, we will create a new class. We will call it Entity, and we will try to replicate our entities in game. So we will have the address of the object, but also the health and our predisposition. We can now add some more class variables, which will be the local player, it will be an entity, and the entity list, or the entities, which will hold all of the entities. Let's also add a variable to hold our client module. Now, before we can do anything with these lists and our local player, we will have to create some sort of main method that keeps everything together. In our main, we will create a new instance of our program called the start method. This will cause the render method to run, and we will also create a new thread that will run in the background. This new thread will be our main logic. We use this because we don't want to put too much code in our main. Now that our main logic will be running when we start the application, we can create a while loop that is always running and do some updating entities and the local player. We will also give the client variable its value by using swed.getModuleBase. Then we will use the name of the module, which is client.dll. Now, instead of cluttering this while loop with a lot of code, we will create a new method that's called updateEntity. It will have one parameter, entity, which will be the entity we're going to update the information about. So inside of this update entity method, we will use the Swedz library to read the health, but also the position. However, we haven't loaded or used our offsets in our program yet, so let's create a class real quick for that. Now we can use the offsets to read our health and our origin or position. This method assumes we have an address, but we would have to add it before we call this method. So in our while loop, we will read the pointer that leads to our object, then call the update entity, which means we will also have to add the local player address, and whilst we're at it, we will add the EntityList address. Let's try writing to the console our local player's health points. And as you can see, it displays our health. If we go in game and change the health points, it also changes in our program. That's amazing. Now let's add the other entities. To do that, we will create yet another method, this one called update entities, plural. It will loop through 64 pointers and reading the pointed to address. We can read the first address by using Swedz.readPointer, the client, then our EntityList offset, but we will also add I times 0x08 because pointers in 64-bit are 8 bytes and the pointers seem to be 8 in hex apart. We will read both pawns and observers because we can tell them easily apart since observers will be duplicates. We will check if the current pointer leads to nowhere. If so, we skip the current iteration and go to the next. If this pointer leads somewhere, we will create a new entity, assign the entity's address to the temporary address we created above, then update the entity. Before we add this entity to the entity list, we will perform a check to see if the health is outside of the bounds, which means if it's less than 1 or greater than 100, we will skip this entity as well. Before we add this entity to the entities list, we will have to check whether it's a duplicate. Remember, we read both pawns and observers, so there is bound to be duplicates. We can check if it's a duplicate by using the .any method, then specifying that it's our element's origin.x axis that we're comparing. So if the two entities have the same x-axis value, we will not add the new entity. And finally, we can call our update entities method, but let's add a breakpoint so we can inspect the entities. Now, if we add the entities to the watch list, it should be populated with the correct amount of entities. Here we can see 8 entities, and we're 8 entities in game. So, Sounds about right. We can inspect the attributes of these entities. Here we had a health of 55. That's our character. We have 55 health points, and the others will have other health points. We can also see in Sheet Engine that the addresses that our entity list in program are the same as what Sheet Engine tells us. So it looks real good. Let's test by writing it to the console again, but with a list of entities instead. So we will loop through each entity of the entities and write out their health and position. We will clear the console so it's new every time, and also wait a bit so it's not that instant. But before we run it again, let's draw our menu with ImGui. We will need to be using ImGui.net as well. Would you look at that? All the positions and a beautiful menu. And look how far we have gone within one video. That's pretty amazing. We can see all of the entities. We can track their position and their health. So now it's very easy to just create our ESP or Aimbot or whatever we want, because we have already created the basic or the base structure of our sheet. So good job if you reached this point, and I'll see you in the next tutorial. See you guys. Bye.